I'm Anil Kumar sharing with you a question from the test paper. We need to write equations of line in different forms. So I'd like you to pause the video, copy the question, answer, and then look into my suggestion. The question here is, write vector, parametric, and symmetric equations for the line 3x minus 4y equals to 0. Now we are working in R2. We are given scalar equations. We are given the scalar equation which is 3x minus 4y equals to 0, right? You need to write this in different forms. Well, you have learned many methods by now to write this equation. The method which I will use is to use normal of the line. So whenever you're given scalar equation, you can read normal. So what is the normal of this line? So normal vector n will be 3 minus 4, right? So once we know the normal, you can find the direction. Especially in R2 is very easy. Just flip it, so you get 4 and 3. And change one of the signs. Since this was minus, I made it positive. Do you see that? So that becomes the direction vector for us. Now, once we know the direction vector, it's easy to write vector equation. We just need a point. Now, if I substitute y as 0, I get x also as 0. So just place a value for y to get the value of x. You could do anything. So if I write 3, for example, for y, then x will be 4. Is it okay? We could use that value also. So there are different values which you can use. Let's use the value 3 and 4. So if y is equal to 3, then in that case you can write this equation as 3x minus 4 times 3 equals to 0, or 3x equals to 12. X is equals to 12 divided by 3, which is 4. So you get your point. Let's call this point as x value of 4, y of 3, right? Okay. But in any case, I would have definitely used point 0, 0 in my calculations. Since if I write 0 here, I get 0. So that is origin. So I will use this point. But as an alternate, I'm using that point. Correct. So with that, we can get the vector equation. So the vector equation will be xy equals to the point, which is 4, 3, plus parameter t and the direction also 4, 3. Okay. You see that? So we get this point. Okay. Well, I would have preferred using 0, 0. Anyway, so we have this point. Now, from this equation, it's very easy to write the parametric equation and the symmetric equation. You need to isolate t to do so, right? Now, what I will do here is provide you with simpler solution and a faster one. So what we will do here is, as I was saying, we'll use 0, 0 as our point, since if I put 0 here, I get 0 for x also. So I have a point 0, 0 and the direction we just found as 4, 3, right? 4, 3. So we could write the equation as xy equals to, so I'm just writing 0, 0, not required, plus t times 4, 3, right? So that is what it is. Or directly t times 4, 3. It's a direct variation, right? Okay, so this is what we get. And to write this in parametric form, we have x equals to 4t, right? Y equals to 3t. So that becomes parametric form, correct? And to write it in symmetric form, we need to isolate t, right? So we can write x over 4 equals to t, and we can write y over 3 equals to t, and then from here we could always write x over 4 equals to y over 3, right? So that becomes the symmetric form. Correct? So this is the symmetric form. Now, as an exercise, what you can do is you can find these forms from this equation also, right? Which I've left purposely for you. So I'll prefer, whenever equation is given like this, we know that goes through the origin. So origin is a good point to take. Take origin as your point. You could find direction by many different ways, but finding from normal is a good idea. Use this direction. Write down your vector equation, which is simplest form, and then isolate t, equate t to write symmetric form. I hope that helps. I'm Anil Kumar, and I hope you find it interesting. Thank you, and all the best.